Find the local maximum and minimum values and saddle points of the function here. So first we need to find the critical points. We find partial derivative of f with respect to x and with respect to y, which is 3x squared plus 0 minus 6x minus 9 plus 0, and partial derivative with respect to y, 3y squared 0 minus 6y 0 0. Okay, and we set these 0 and solve for x and y. So first equation we can solve for x. It's a quadratic equation in x, and here this is also quadratic, so we can solve for y as well, so we can get the critical points. So from first 3, 6, 9, we can factor 3 out first. X squared minus 2x minus 3 equals 0, or 3 is trinomial, so we can factor as a product of two binomials. X squared means x times x, 3 times 1 3 to get negative, and here is negative, so negative here, positive here. So you can check your factoring by pulling this out. That is, so 3 has no contribution, we can divide both sides by 3. So x minus 3 0 means x equals 3, and here is x equals negative 1. Okay, from the second, so from here this implies we can factor 3y out, so we get y minus 2, okay, equals 0. So this implies 3y 0 means y 0, y minus 2 0 means y is 2. So we got x 2 values and y 2 different values, and we find them independently. That means we got 3 0 3 2, negative 1 0 negative 1 2, 4 critical points, because this y is not based on any of these axes. We found them independently. Thus the critical points are 3, let's just take x equals 3, and we have two different y values, 3 0 3 2. Now we take x negative 1, so negative 1 0 negative 1 2. Now we need to test each of these 4 critical points to check if they produce local maximum, minimum, or saddle points. In any case, we need to first find the discriminant. That means we need to find partial derivative of fx with respect to x one more time. So find derivative of this with respect to x, 6x minus 6, and partial of this fx with respect to y. So with respect to y, there is no y, so 0, and we need to find partial of fy with respect to y, fyy. So partial of y with respect to y is 6y minus 6. Then the discriminant is just fxx, fxy, fxy, fyy. Let's compute this 2 by 2 determinant, or this product, 6x minus 6, this is 0 0, 6y minus 6, multiply minus 0, so this is, in fact this is 6x minus 1. We can factor 6 out, 6x minus 1 times 6y minus 1, which is 36 x minus 1 y minus 1. We didn't have to multiply, but anyway, this is the discriminant. Now we need to test this discriminant for each of these critical points, so separately. So number one, for this critical point 3 0, So what is the discriminant? This is x value and this is corresponding y value. Discriminant at 3, 0 is 36, x is 3 minus 1, 2 times y is 0, 0 minus negative 1, 0 minus 1, negative 1. So this will be a negative number. Okay, negative number. When we get discriminant a negative number, that implies the function has a saddle point at this. Okay, so f has a saddle point at 3, 0, at this critical point. And in fact, the saddle point itself is, the saddle point is x, y. We need to find the corresponding z value. We plug x and y into the function, into the original function here, then we get the corresponding z. Okay, third coordinate. So this is 3, 0, and I'll come back calculating this. So that's negative 17. Okay, so let's move and do the same thing for second critical point, 3, 2. Okay, for second critical point, 3, 2, we first compute the discriminant. Okay, d equals, and we have found d here. So let's plug in the x equals and y equals. X equals 2, x equals 3, y equals 2 value. So that gives 36 times 3 minus 1, 2 times 2 minus 1, 1. That's 72. But what matters is whether this is positive or negative. So 72, which is positive. That means we can get either a local minimum or a local maximum at here. For we need to find second derivative f(x(x) at this point. And where is f(x(x)? If we go up, we can see here is f(x)(x). Okay. If the discriminant is negative, then saddle point done. If the discriminant is positive, then we have to do further. Just find second derivative at this point 3, 2, at this critical point 3, 2. Plug in 3, 2. There is no y involved, so just x. That is 6 times 3, 18 minus 6, 12, which is positive. Okay, this matters. And d positive and second derivative also positive means f has a local minimum at this point 3, 2. This is the location, and the minimum value is, go up, go back to the original function and plug in 3, 2. So a local minimum at this point, and the minimum value at this point. The minimum value is, just plug in into the function, and the minimum value is negative 21. So let's do for third critical point, negative 1, 0, same type of work. For the third critical point, negative 1, 0, so we have d here, plug in x equals negative 1 and y 0. Okay, negative 1 minus 1, this is negative number and this is negative, so when we multiply we get positive. So d positive means we need to find second derivative f(x)(x) at negative 1, 0. So here is 6x minus 6. Okay, that's f(x)(x). When we plug in negative 1, 0, so it becomes just negative 1. This becomes negative number. Okay, so I made a mistake here. It's negative, so let me correct that. So we get f(x)(x) negative. That means the function has a local maximum at negative 1, 0. Okay, that's the location, and the local maximum value is, just plug in negative 1, 0 into the original function, we get 15. And finally we need to do for the fourth critical point, which is negative 1, 2. Okay, let's do that. At the critical point negative 1, 2, the discriminant becomes negative. Just plug in x equals -1 and y equals 2 here. Okay, 36 times -2 times 1, which is negative number, and when discriminant is negative, f has a saddle point at this -1, 2, and the saddle point in fact is x, y. We need to find the corresponding g, or function value. Plug in -1, 2 into the function, original function, you get 11. Okay, final